Hi everyone and welcome. Thank you for joining me today for a quick overview of how to implement fine-grained access control with Amazon Cognito Identity Pools. My name is Mahmoud Matouk. I am a solutions architect with AWS Identity. In this overview, I will explain the options for fine-grained access control and will also show you a demo of some of the new features that puts even more control in your hands. But first, let's begin with when should you use Amazon Cognito Identity Pools and what are some of the use cases that can be solved with using this service. Identity Pools is a credentials broker service that allows you to get temporary and scoped AWS credentials for end users who have been already authenticated in your system or your application. Through an identity pool, you can exchange a valid token from one of the supported identity providers with temporary AWS credentials from Simple Token Service or STS. It allows you to get both guest and authenticated access to your users. It also allows you to get credentials for external tools or developers in your organization that need limited access to certain resources in your AWS account. This is usually better than having long-lived credentials and allows you to manage authentication of these tools and developers in your primary identity source rather than having to create long-lived credentials or users in the AWS account. Identity Pools service supports multiple identity providers, including Amazon Cognito user pools, social providers, and standard SAML or OpenID Connect providers. And there are several options for fine-grained access control that I will talk about in this session. Let's look at the 10,000-foot view of how to get these temporary credentials. First, your application will authenticate the users using one of the supported identity providers. After successful authentication, your app usually gets some sort of tokens from these IDPs. You can then make a call to Cognito Identity Pool to get AWS credentials based on the identity proof you have. It could be a SAML token, it could be a JSON Web token, or a specific social provider token. In this case, Cognito is going to verify the token with the issuer, and if the token is valid, Cognito will assume an IAM role and return credentials to your application in the form of an access key ID and a secret and a session token. These are usually the form of credentials you need to use with the AWS SDK. Your application then can use these credentials to access AWS resources based on the permissions attached to this IAM role. And this brings up the question, what are the options for fine-grained access control? Can it be dynamic or is it a fixed set of permissions and fixed set of rules that I can assume? Let's look at the options. Credentials returned from identity pool is usually obtained by assuming an IAM role. So access control will always come down to which IAM role to assume and what are the variables that can be presented into the IAM policies to further allow or deny actions in these policies. The first two options for access control are simple. You have an IAM role assigned to unauthenticated or guest access. If you choose to support guest access, you will need to map this to an IAM role, usually with a restricted access based on what guest users are allowed to do in your application before they sign in. And you also need a default IAM role for authenticated users, which will be used by default if you don't have any other fine-grained access control to choose a role based on rules or from the token or other settings in the identity pool. This will be the fallback option to assume for authenticated users. The third option is rule-based access control, and this gives you more flexibility to choose which IAM role to assume based on multiple factors. First, you can choose IAM role from the token itself, from the ID token, and this is exclusive to identities that have been authenticated with Amazon Cognito user pools. You can add users to groups in the user pool and map these groups to IAM rules, and this will determine which IAM role to assume for this user. I will explain this in a minute. The other option for rule-based access control is to choose rule based on values of the claims or attributes in the token. This allows you to check values of certain claims in the token and create matching rules to decide which IAM rule to assume. And the last option and the newest one is using attributes for access control. With this feature, you can choose any attribute or claim in the token to be passed as a principal tag to the IAM policy. You can then reference these principal tags in the policy to drive access control. This allows you to create simpler policies that can scale and easier to maintain, and it allows you to control access by adjusting user profiles in the identity source or adjusting resources on AWS side using tagging or naming, for example, rather than adjusting the policy itself. Let's dive slightly deeper in each one of these approaches and see how it works. First, looking at rule-based access control. In this approach, user will authenticate with an external identity provider, could be an Amazon Cognito user pool or other provider. In all cases, your application will get a token after authenticating the user. This is an example of a token from a user pool. Note the Cognito preferred role claim in this token. This is calculated based on the group membership of this user in the user pool. Now, in the identity pool, you can configure it with multiple options. It can be configured to choose rule from token. So if user has been authenticated with a user pool and it's coming with a preferred rule claim in the token, Cognito will assume this rule and return credentials that's mapped to this IAM rule. If you have a different provider or you want to choose rule based on different factors or other factors or attributes of the token, then you can select the option to choose IAM rule with matching rules. And this allows you to add multiple sequential matching rules, as in the screenshot here. Each rule will compare a claim from the token to a fixed value. And if the rule matches, the assigned IAM rule will be selected. Order of these rules matters here. The first match will decide which IAM rule to assume, and if there is no match, you can decide whether to deny the access or just fall back to the default IAM rule. In all cases, you will get access key ID and a secret and a session token, and then your application can use these credentials to access AWS resources with the SDK. With rule-based access control, you can satisfy a wide range of use cases, usually when permissions are tied to a role in your system, like developers, admins, network engineers, and so on, or even for your customers if you can categorize customers into roles like a premium customer or regular customer. But when permissions are tied to a number of user attributes or changing runtime factors, then you need a dynamic policy that can adapt to these variables. For example, if you have thousands of AWS resources in the account, between buckets, instances, stacks, and so on, and you want permissions to be based on tagging of these resources and maybe user team membership or group membership. Same is true if your access control is based on attributes that will be maintained in the user profile and the identity provider, or even added to the token during authentication at runtime. And this is where attributes for access control can help. Using attributes for access control feature in identity pools allows you to pass attributes from the token as principal tags to the IAM policy. You can then reference these principal tags in the policy to make it more dynamic. Let's look at an example to make this clear. Let's say that Adam from legal department needs access to be able to list all files and buckets owned by his department. He also should be able to read files in these buckets as long as the security level on the file matches his clearance level. Let's also assume that you have several other departments with similar access needs, like HR department, engineering, IT, and so on. Using attributes for access control, Adam will be authenticated and his token will look something like this. It has an attribute indicating his department, could be also a group membership, and it has an attribute indicating his security clearance level. In this case, in the identity pool side, we can select clearance and department claims to be passed as principal tags. We can then reference these principal tags in the resource section, so you can say that these actions apply to resources that match Adam's department. You can also reference principal tags in the conditions section, for example, to compare the clearance level of the user to a value of a tag on the file. You can now manage access by changing user profile on the IDP side or changing tags on the file rather than changing the policy itself. All right, now it's demo time. Let's try to implement this example and see what it takes. Here is what I will be doing. I will be using Amazon Cognito user pool as the identity source to allow Adam to sign in. I will first walk you through the console to see some of the configurations I have on the identity pool and the IAM role and policies that will allow Adam access to S3. And to test this access, I will be using Postman to sign in, get the tokens, get the credentials, and attempt to access the S3 bucket and files. In your application, you will be usually using the AWS SDK to perform these actions, or even the CLI if you want to write some scripts for tools or developers and so on. All right, let's first look at the identity pool configuration. Here I have created an identity pool. I've assigned a guest role and authenticated role. We will take a look at this role in a minute. All other settings are defaults except for authentication providers here. I added my user pool and application client as the identity source, and as you see, you have wide range of other providers that you can choose. And under the identity source here, you have different configurations as explained on how to choose the IAM role to assume for users who have been authenticated with this identity provider. For example, you can choose the default rule, or you can choose rule with matching rules. As I mentioned before, if you select this option, then you can add these sequential matching rules, and they will be executed in order, and each rule will compare a claim from the token to a fixed value, and this will decide which IAM rule to assume. You can also choose rule from token, which again is going to just assume the rule that is defined in the preferred rule in the token. Now let's select the default and move to the second section, and this is the new section that indicates using attributes for access control. From here you can select to disable or enable this feature. You can select default mappings, which is going to just pass the subject and the audience as principal tags to the policy, or you can choose custom mapping that will allows you to decide which attributes to be passed as principal tags and what will be the name of the principal tags. In this case, I'm configuring the attributes for access control to pass the clearance and the department from the token as clearance and department principal tags to the IAM policy. Now, let's take a look at this IAM rule and see how it is configured. All right. The rule has two types of policies. It has a trust policy that determines who is able to assume this rule, and it has permissions policy that determines what are the permissions that this principal that assumes this rule will have in your AWS account. Let's first look at the trust policy. The trust policy is simple. It just allows assume rule with web identity and allows the use of session tags to Cognito identity service. And it adds some conditions to restrict this policy to the identity pool that I have created. This is the identity pool ID, and it makes sure that this is for authenticated users. Let's now look at the permissions policy. Permissions policy will allow S3 list to all resources that ends with the user's department. So here I'm referencing the principal tag department that will be coming from the department claim from the token. And this policy also allows get object, which allows the user to read files or download these files to the same buckets, the buckets that ends with the user's department, but also adds a condition that the clearance level of the file, this is a tag on the file, must match the clearance level of the incoming user. This is from the clearance principal tag that we configured on the identity pool. Let's also take a look at the S3 configurations and what buckets and files we have there. On S3 side, I have three buckets. Two buckets belong to the legal department, and this is indicated by the dash legal at the end. And Adam should be able to list files in these buckets. I have another bucket for engineering department, and Adam shouldn't be able to access this bucket. And in these buckets for the legal department, Adam should be also able to read the files as long as the clearance level matches between the file through the tagging and between the token with the clearance level that's coming from the identity source. All right, let's test these permissions. First, Adam needs to sign in and get a token. And for that, I will be using the default OAuth 2 plugin from Postman. And I configure this to point to my Cognito user pool. Again, this authentication will be different according to which identity source or identity provider you use. Here I will get a token for Adam, and this will pop up the hosted UI for Adam to sign in. After successful authentication, I have my tokens here. So this is the ID token that I need to use with the identity pool. Before we proceed, let's take a quick look at this token and see what are the contents of it. Looking at this token, you have many claims here, but what we are concerned with is the clearance, which is confidential, and the department, which is indicated here as legal. And these are the two claims that will be passed as principal tags to the policy. And as we got the token, the next step is to call the getID method of the identity pool. And this takes the parameters of identity pool ID. This is the identity pool that I just showed you in the console. And then it also takes logins construct, which maps an identity provider and the token that will be verified against this identity provider according to the configurations we have on the identity pool. So this is my user pool here that I used to sign in Adam. And this is the variable of the ID token that I just got from the previous step and I saved it in the variable. If we hit this endpoint, we should be able to get an identity ID for this user. Then we take this identity ID and go to the next API call to get credentials. The get credentials for identity needs an identity ID. This is the one that we got from the previous call, and it takes the same logins construct. So it takes again a mapping between the identity provider and the identity proof, which is the ID token we got for Adam. Hitting this API is going to return me the temporary credentials I'm looking for in the form of an access key ID and a secret and a session token. So I'm going to again save these credentials in local variables here. This is the access key ID, and this is the secret. And this is the session token. And the good thing is that this is temporary credentials according to the configurations of the IAM rule, so I have also an expiration time here. Now let's try to use these credentials to access S3 and try to list the files in the bucket that Adam should have access to. And I'm doing this by just hitting the endpoint for my bucket, and this is constructed as you see here. This is the bucket name, and then the S3 endpoint for the region where the bucket lives in. Just hitting this endpoint with no other parameters is going to list the files in this bucket. Let's first try this without any authentication, and I should get access denied. Now let's try to make this call again using AWS signature, which will read the access key ID and a secret and the session token from the variables I just got from the identity pool. And this will succeed, and Adam is able to list files in this bucket. I see here that I have test file 1, test file 2, and test file 3. If I try to list files in another bucket, like the engineering bucket, Adam doesn't have access to this bucket. But if we try another bucket that belongs to the legal department, Adam should be able to list files in this bucket. And as you see, this succeeds. We have archive 1, archive 2. Now let's try to read one of these files. So let's try to read archive 1. And Adam will get access denied because his clearance level doesn't match the clearance level on this file. So let's go to the file and change the clearance level to match Adam's and try this again. I will get to this file and add the tag that is required for this policy. And this tag is clearance, and the value is confidential. Save these changes, and let's try to access the file once again. And now Adam can access the file because the clearance level matches between the user profile and the tag on the file. So now to conclude this scenario, you can control the access by adjusting the user profile attributes on the identity source, or by adjusting the AWS resources by adding tags or changing the names of these files. Different services have different levels of support for session tags, and you can do much more than that with just a simple policy that scales and doesn't need to change, and will be dynamic based on these attributes that you can pass to the policy as principal tags. Thanks again for your time and have a good day.